All right, welcome back, students. Today we're going to review Chapter 1. We have a test tomorrow, so I'm going to kind of walk through all the main questions that you're going to see on tomorrow's test. There's going to be a few that I'm going to skip in here just because we skipped either those lessons or we may reword things on the test, so it won't be the direct questions here in the review pages. If you want to turn to page 79 in your textbook and follow along or fill in as we go. These are going to be the same test type questions you're going to see on tomorrow's test. So go ahead and fill in your textbook as we go. We're going to start here with the first question on properties. Remember, properties fall from lesson 1.3. So if you're struggling with some of these questions, you can go back and check in lesson 1.3. As we look, they want you to find the property that matches the equation that is up here. So as we go through, remember the identity property of addition is anything that we start with a number and then we add 0 to it, and then we get that same answer. So we want to keep the number's identity using addition. So we're adding 0. So the equation that matches that would be this one here. 0 plus 16 equals 0. We're adding 0 to it. The identity property of multiplication then is the equation that we can use multiplication to start with a number, multiply it by 1, and keep that same number. So the identity property of multiplication is multiplied any number by 1. And that would be 1 times 9 equals 9. For the commutative property, commutative means that we want to flip-flop the numbers or change the order around. So the commutative property of multiplication would be an expression or an equation that we have rearranged the numbers into a different order. So the commutative property of multiplication would be 87 times 3 would give you the same answer as 3 times 87. Then for addition would be the same thing where we flip-flop the order except using addition. That would be 23 plus 4 plus 109 is the same as flipping the order and getting 4 plus 23 plus 109. For associative property, try to remember that the order does not change. The numbers stay in the same order. The only thing that changes is the parentheses. So instead of grouping one set of numbers, you would then group another set of numbers. The associative property of multiplication would be this first problem here, which is 15 times the quantity of 7 times 9, is the same thing as regrouping 15 times 7 times 9. That would be the associative property using multiplication. The associative property using addition would be then 13 plus the quantity of 3 plus 7 is the same as regrouping it 13 plus 3 first and then adding 7. If you're still struggling with properties, you can go back to lesson 1.3 and review that lesson there. Question number 2 down at the bottom is from lesson 1.1, talking about 10 times more or 1/10 of a number. Now remember, when we want 1/10 of a number, we mean 10 times less than that number, which would mean we would be removing a 0 from that value. If we want 10 times as much as, we're talking 10 times bigger, so we are adding an extra 0. So we're going to go through these and look at them. Are they true or false? On the first one, we have 170 is 1/10 of 17. So is 170 10 times smaller than 17? No, 170 is actually larger than 17. So this would be false. 2b is 660 is 10 times as much as 600. 660 is not 10 times as much as 600 because it has just 660 and not 600. And to be 10 times more, it would have one extra zero. It does not. It is false. 900 is 1/10 of 9,000. Now, this is a true statement because 900 is 10 times smaller than 9,000. It has one less zero than 9,000. And 4,400 is 10 times as much as 440. 4,400 is 10 times more than 440. That is also true because it is just 440 with one extra zero. That means 10 times as much. So it would be false, then false, true, then true on these. Again, if you're struggling with 10 times as much or 1/10 of, you can review lesson 1.1. Question number 3, select other ways to write 700,562 and mark all that apply. When it says mark all that apply, we're talking that there are going to be more than one answer correct here. So we want to go through word form as well as expanded form. Here's the standard form. We want word form and expanded form for this value here. So when you're looking at expanded form, really you're just looking for the digit, these digits here, and the place values. So these would represent the place values that those digits would be in. So is there a 7 in the 100,000s place? That is correct. Is there a 5 in the thousands place? There is not a 5 in the thousands place. So therefore A is not correct. B, 700,562. To read that, 700,562. That is correct. That is the word form for this value here. C would just be the value of each of those digits. The 7 is worth 700,000. The 5 is worth 500. The 6 is worth 60. And then obviously the 2 would be worth 2. That is correct. That would be the expanded form that you guys maybe used last year in 4th grade. The last one here would represent the place values and the numbers that would be in there. So do we have 700,000s? That's correct because there's a 7 in the 100,000s place. 5 in the hundreds? That's correct. And then 62 tens. 62 tens, think of even as money. If you had 62 $10 bills, you wouldn't just have 62, you would have 620. So this value here would be 620. Therefore, we do not have 62 tens, so D is not correct. The correct answers here would be B and C, the word form and the expanded form. Question number 4, Carrie has 140 coins. She has 10 times as many coins as she had last month. How many coins did she have last month? And we have to read that again carefully because a lot of the times we see 10 times as much and we want to multiply that by 10. But it says she currently has 140 coins. That means it is 10 times as much as she had last month. So last month she had less. She had 10 times less last month than she does right now. So we are looking for what is 1/10 of 140. So 1/10 of 140. Well, what number is 10 times smaller than 140? Well, remember, when we said we want 1/10, we are taking off a 0. So last month, she had 14 coins. 14 coins. Question number 5 is an expression problem. Valerie earns $24 per hour. Which expression can be used to show how much money she earns in 7 hours? So in order to solve this, anything times per hour would be multiplication. So we're really doing 24 times 7. But in order to solve this, they want you to show the distributive property. Okay, instead of just multiplying 7 times 24, we want to represent the distributive property. When we're working the distributive property, we want to break 24 apart into 20 plus 4. And then we're going to multiply that by 7. So we want to multiply each part by 7. So we're thinking we want to do 7 times 20. We want to do 7 times 20. And then we're going to multiply the other part, 7 times 4. And when we're done, we want to add those two answers together. So distributive property is break it apart into two numbers that add up to it, and then multiply the single digit number by each of those. So 7 times 20, 7 times 4, and then you add those answers together. The correct answer would be B. Also, one way to solve this, if you're confused about which one is correct, you can just simply take 24 times 7, which is going to give you 168. And then you can multiply each of these out to see which one also gives you 168. So the first one, we're thinking 27, and this side's 11, and we just did order of operations, so we're going to add those two parenthesis answers together, and we get 38. The second one, this would give me 7 times 20, 140. 7 times 4, 28. And then add those two together, which is 168. C would be 27 and 11. And we're going to multiply those together, which we know 27 times 11 is not going to give us 168 like we're looking for, just sheer by the fact that 1 times 7 is 7, the number is going to end in a 7. But we can still go ahead and multiply this out and get 297. And then the last one, this would give me 140. This side would be 28, and we're going to multiply those together. We know that's not going to give us 168. So the only correct answer here would be letter B. So you can use the distributive property, or you can solve the problem and then also solve each of these expressions to see which one would give you the correct answer. For number 6, we're not going to use the explanation part. Tomorrow, you're going to have a table that is going to be set up just like this, and you're going to have to solve each of the expressions there with powers of 10. So this lesson here would be powers of 10 and exponents. And remember, 6 times 10 to the 0 power, 10 to the 0 power equals 1. So this first one is just saying we're doing 6 times 1, and that answer is going to be 6. 10 to the first power is just 1/10. So we're talking 6 times 10, which would give us 60. A 6 with 1 0. The exponent tells us how many zeros there's going to be. 6 times 10 would be 60. 6 times 10 to the second tells us there's going to be a 6 and 2 zeros. That's the same as 6 times 10 times 10, because there are 2 10s there. The answer would be 600. And then 6 times 10 to the third power is just 6 times 10 times 10 times 10, or 6 times 1,000, which just gives you 3 extra zeros, a 6 with 3 zeros. So make sure when you're solving those powers of 10 questions that you make sure you count how many extra zeros. The exponent will tell you how many zeros in the product. Turn to the next page. Question number 7. It is 3,452 miles round trip to Craig's aunt's house. If he travels to her house 3 times this year, how many miles did he travel in all? Now, we had a problem similar to this on our homework earlier in this chapter. And we had the distance just to the grandma's house. This case, Craig's aunt's house. But we have a round trip. Round trip means the distance from there and back. So we're looking at, if we draw a picture here, we have Craig and we have his aunt's house from here to here. He's going to fly there and fly back, and that's going to be 3,452 miles round trip. In this case, we want to know how many times he does that, or how many miles he goes in 3 times traveling that way. We do not have to double that distance because that is round trip. The problem we had earlier in the chapter, you had to double it because that was just the distance to the aunt or the grandma's house, and then you had to find it back. So in this case, we just need to solve 3,452 times 3 because we know the full distance here. So 3 times 2 equals 6. 3 times 5 would be 15. 3 times 4 is 12, plus 1 is 13. And 3 times 3 is 9, plus 1 is 10. The answer is 10,356. Remember on your test, you can enter your distance there with a comma or without a comma. We are going to skip questions number 8 and question number 9 on your test. We will not be doing those problems because they came from sections that we either skipped or we've reworded some of the problems, so we won't be doing any extended responses. On to the next page. Question number 10 says we want you to come up with the numerical expression that shows how much he spent from the story problem here. So Carmen buys 8 plates for $1 each. He also buys 4 bowls. Each bowl costs twice as much as each plate. The store is having a sale that gives Carmen $3 off the bowls. So we want to go back through here and set this expression up. That solves the problem here. So first, we know he buys 8 plates and each plate is $1. So we know that's going to be 8 times 1. So letter A, B, C have 8 times $1. D does not follow that. So we're going to go ahead and eliminate that right now. He then buys 4 bowls that are each twice as much as the plate. Well, we know that the plates were $1, so the bowl must be $2. So we have 4 times 2, which is this one. The store is having a sale that gives them $3 off the bowl, which means we're going to subtract $3 just from the bowl side. So that was where the -3 comes in inside of this bracket, because that's the side with the bowls. So the correct expression here would be letter C, 8 times 1 plus the amount for the bowls, which is 4 times 2, and then minus $3 off for the bowls. Question number 11 then says, evaluate the numerical expression. Remember, the word evaluate just means solve. So we're going to go ahead and solve this problem here. I'm going to go ahead and rewrite the problem off to the side. Close the parentheses, times 3. And we're going to use the phrase PEMDAS to solve here. Remember, PEMDAS is we're looking for parentheses first. We are not going to have any exponents in this chapter or in 5th grade in order of operations. We are going to have multiplication and division. Remember, we work this from left to right. And the same holds true for adding and subtracting, left to right. So as we look at this, we're looking for parentheses first. We have parentheses here, and 65 plus 7. So we're going to solve this. 65 plus 7 is going to give us 72. And then we're going to rewrite everything in the next row. Plus 2 comes down, times 3 also. Now we have addition and multiplication. Multiplication comes first, so we're going to multiply 72 times 3. Multiplication is more powerful than addition, so therefore that's why we do multiplication first. We go off to the side, we do 72 times 3, and we get 216. We're going to go ahead and write that below. We add 2 to that answer, and we get 218 as our final answer. Question number 12. We have an adult elephant eats about 300 pounds of food each day. Write an expression to represent the number of pounds of food a herd of 12 elephants eat in 5 days. So when we write an expression, all we want to do is set up the problem. We don't want to solve it. We just want to set the problem up. So we know that each elephant's going to eat 300 pounds per day. And we're going to multiply 300 pounds by 12 because there are going to be 12 elephants in that herd. And this is going to represent how much food those elephants eat, the herd of elephants, eat in 1 day. So they eat 300 pounds times 12 in 1 day. And then we want that for 5 days. Now, you can put the multiplication times 5 either at the beginning here, multiply this expression 300 times 12 by 5 here, or you can also multiply by 5 afterwards. Either way, you're still going to solve the 300 times 12 first, and then you're going to multiply it by 5 because you're going to have that over 5 days. So either expression would work. Tomorrow on your test, that's going to be a drop-down box, and where you will have to choose the correct expression. You won't have to create it yourself, but you will have to then choose which one matches that story problem. Question number 13, we are going to go ahead and cross off. We will not be explaining the expression problem. You may also cross off questions 14 and 15. As well as number 16. On to question number 17. If Jeannie eats 1,840 calories a day, how many calories will she have eaten after 182 days? So we have 1,840, and we're going to multiply that by 182. Now this is going to be a 3-digit multiplication problem. Remember, the key to doing large multi-digit multiplication problems are a few things. Number one, you need to make sure you know your multiplication facts. If you have to look back at a multiplication chart, please do so. But remember, you need to start studying those by 5th grade. We should have our times tables up through 9s memorized. So make sure we're studying those. Second thing students often make a mistake is when they move to the next place value, they forget to drop a 0. And in this case, we're going to move to the hundreds place, and we need to drop 2 zeros. So we have 1 0 when we move to the 8, and 2 zeros when we move to the 1. One other common mistake is students make simple addition mistakes or simple multiplication mistakes as we go through here. So make sure you can eliminate those silly addition mistakes as you're adding at the very end. And the last thing we recommend is make sure you keep your numbers organized. We don't want to have our numbers all out of line here, and then when you try to add, you're not sure of which number to add. So make sure you keep everything nice and organized in your row. All right, as we multiply this, we're going to go 2 times each number at the top. So we're going to take 2 times 0, which is 0. We're going to take 2 times 4, which is 8. The 8 comes down. 2 times 8 is 16. And we're going to carry or regroup the 1. And then we're going to take 2 times the 1 and get 2 plus 1 equals 3. We've already dropped our 0. And then we move over to the 8. We're going to take 8 times this 0 and get 0. 8 times 4 is 32. Carry my 3. 8 times 8 is 64. Plus 3 is 67. We're going to go ahead and carry our 6. 8 times 1 is 8. Plus 6 is 14. We then drop our 2 zeros down into the next row. We go 1 times 0 is 0. 1 times 4 is 4. 1 times 8. And 1 times 1. These numbers that we regrouped will go away. We then add all of this up. Now notice all my rows are organized here, so we need to make sure then we add correctly here. The first column adds up to 0. 8 plus 0 plus 0 is 8. 6 plus 2 plus 0 is also 8. On the next one, I'm going to go 3 plus 4 is 7. 7 plus 7 is 14. I'm going to carry my 1. 8 plus 4 is 12. Plus 1 is 13. Carry my 1. 1 plus 1 plus 1 is 3. And our answer is 334,880. And that will also go right here. Now, when you're entering your answer, you may enter it without any commas, or you can go ahead and place that comment in there. It will accept both answers. Question number 18. There are 8 teachers going to the Science Museum. If each teacher needs to pay $15 to get inside, how much did the teachers pay? So we have 8 teachers, each paying $15. The word each tells us we're going to multiply. So it should be a simple multiplication problem. 15 times 8. 8 times 5 is 40. Carry my 4. 8 times 1 is 8 plus the 4 is 12. Our answer, the teacher should have paid $120. Question number 19, select all the ways to write 50,897. Mark all that apply. Again, mark all that apply tells us we are going to have more than one correct answer. If you remember from the first time we did this problem, we're looking for place value. So the 5 is in the 10,000s place, which is correct. The 8 is in the hundreds place. That's also correct. The 9 is in the tens place, which is true. And a 7 in the ones place, which is also correct. If I were to multiply all of these, I would end up adding them together and still get that number. So that is correct. B, we want to know what's the value of each of these numbers and then add it together. So this is the expanded form here with value. That first 5 is worth 50,000, which is correct. The 8 is worth 800. The 9 is worth 90. And the 7 is worth 7. B is also correct. C cannot be correct because, again, if you're doing the value, that 5 is not worth 5,000. It's actually worth 50,000. So C is not correct. And letter D is the word form, and it's write it how you say it. 50,897. And that is 897. So this is the correct word form for that number there. So the correct answers are A, B, and letter D. Question number 20, select true or false. If you solved those expressions, do you get the value that they say right there? So question 20A is 55 minus 12 plus 2. So we're going to solve parentheses first. We're going to go 12 plus 2 is 14. We have 55 minus 14. You want to just set those up this way. If I subtract, I should get 41, which is true. Value is 41. For part B, we're going to set up 25 plus 14 minus 4. Go ahead and change the board here. And then we're going to take that answer and divide it by 5. So parentheses first. 14 minus 4 is 10. We're going to rewrite everything out. Remember, in PEMDAS, we do division before we do addition. So we're going to divide. 10 divided by 5 equals 2. We're going to then do 25 plus that 2, and we're going to get 27. And again, that is also true. Question 21, Tara bought 2 bottles of juice a day for 15 days. On the 16th day, Tara bought 7 bottles of juice. Write the expression that matches the words. So we're going to come up with the expression that represents that story problem here. So the first thing we need to know, we have 2 bottles of juice per day for 15 days. That means each day for 15 days we buy 2 bottles of juice. Each tells us to multiply. So we're going to go 2 times 15. Board is acting up here. 2 times 15. And then on the 16th day, that just means on the next day. It doesn't matter what number. 16 is not part of this problem here. That just means on the next day, she bought 7 more bottles of juice. So we are adding 7 bottles of juice to our collection. So it's going to be plus 7. 2 times 15 plus 7. Now, you do not need to have parentheses around the 2 times 15 because in PEMDAS, multiplication comes first. So you're going to multiply the 2 times 15 regardless. But if you want, you could put parentheses around that to say do that first. So you take the 2 times 15 first, and then on the next day, add 7 more bottles of juice. Question number 22, last question here. We're talking powers of 10. So select other ways to represent or to express 10 to the second power. Now remember, exponents. Exponents tell us how many times we're going to multiply the big number, the base. So 10 to the second power just simply means that you're going to have 2 10s multiplied together. 2 10s multiplied together. That would be letter F. Also, if I multiply 10 times 10, I'm going to get 100. Which is letter B. It's not going to be 20 because it's not 10 times 2. That does not work for exponents here. We can't just take 10 times 2. It is 2 10s multiplied together. 10 plus 2 doesn't work. 10 times 2 and 10 plus 10 does not work. Exponents are repeated multiplication. So since it's 10 to the second power, you know it's a 1 with 2 zeros. That's what the exponent tells you. Also, 10 times 10. If you have any questions, please message Mrs. Loddock or I. You may look back at this video at any time. Best of luck on your test tomorrow. And again, keep working hard.